Hi everyone, and welcome back. Today we're talking about congruent triangles, which is when two triangles completely match. They are congruent in every way, and we're going to end up describing what this means and proving it as well. But before we get started, let's talk about what it even means to be congruent to triangles. So we know what congruent means. Congruent means same size, same shape. So for two polygons, not just triangles, but for two polygons to be congruent, all the corresponding sides and angles have to be congruent. Okay, if one of them is even slightly off, then it doesn't work. They have to match exactly. So when you're writing down your congruency statement, something that's really, really important is to make sure that you are naming them correctly. Okay, because in order for two triangles or polygons to be congruent, all the angles must be congruent. And so when you're naming things, you need to make sure that the corresponding vertices are in the same order. Okay, so take this example down here. If I have triangle, all right, A, B, C. Okay, and we're going to pretend that angle B here is 100, and then we've got, what does this look like? This looks like a 50, and this looks like a 30. Okay, now according to my congruency statement, it says that ABC, triangle ABC, is congruent to triangle XYZ. In order for this to work, not really straight lines, but it's okay. A needs to match X. X and A need to be in the same spot. And then B and Y need to be in the same spot. And then C and Z need to be in the same spot. And so here you have an example of all the vertices matching up. But if you were to say that A, B, C is congruent, and you were using these two pictures, I'm using these two pictures. If you were to say that triangle ABC is congruent to Z, X, Y, what you have currently said is that A is congruent to Z. And when you look at our picture, A is not congruent to Z. All right, now what I hope you see in this is that the vertices have to match exactly. Corresponding angles have to line up in the name. It's very, very important because when I look at your work, I'm going to go off of your name. And if the name doesn't match what you're trying to say, then you haven't said it correctly. So always make sure that when you are naming triangles, you name the corresponding angles in the same order. All right, now this is just a fancier way of saying the other slide, but a couple things I want to point out to you. Congruency statement. The congruency statement is when you mathematically say that two things are congruent. So technically speaking, all of these are congruency statements. However, this is the one that matters because this is the one that says the two triangles are congruent. Okay, so notice I have triangle ABC, that's this top triangle, and I'm trying to say it's congruent to HJK. Well, A has two congruency marks, and in the other triangle, H has two congruency marks. So A is corresponding to H. So that's why in the name, they match exactly. And then so on and so forth. B is congruent to J, and C is congruent to K, and they all match exactly. Now, in order to prove that two triangles are congruent, you have to first show that all the corresponding angles are congruent and all the corresponding sides are congruent. Okay, that's 6 pieces. One more time, that's 6 pieces. Okay, 3 angles and 3 sides. So if ever I say to list all the congruent parts, you need 6 pieces. All right, now again, another illustration. If you've already taken notes on this, you don't have to take notes on this. But this shows an invalid statement. So if you were to scramble the letters, this would be invalid because B and J are not in the same position. So if you look at our invalid statement, the way this is ordered, B should be congruent to K, but it's not. Okay, so it's very, 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 very important that the angles match up. All right, so what we're going to do for these problems is we are going to write the congruency statements, and then we are going to list the corresponding congruent pieces. Bit of a tongue twister on that one. I'm going to do number 10 with you, and then you're going to do 11 by yourself. So from the get-go, I'm going to name these two triangles. Here's triangle 1, here's triangle 2. Starting with triangle 1 for no other reason than that's how I named it. I'm going to start, my personal trick is I start with the right angle, so J. And then I'm going to go up the first congruency side to K. And then down the hypotenuse to G. All right, that's just my trick. It helps me when the triangles look weird, keep the sides in shape or in order. Because when I do the next one, I'm going to do the same exact thing. I'm going to start the right angle, which is H, go up the one congruency side of G, and then back down the hypotenuse to K. Notice how in this triangle, I need you to notice this, G is not congruent to itself, nor is K congruent to itself. Okay, this is a very important thing to recognize. Because K, this angle of K is congruent to this angle of G. All right, and this trips some people up, so make sure you don't fall for it. Now I'm going to list the 6 corresponding congruent pieces. So first off, we're going to start with the angles. Again, I'm going to start with my right angle because angle J is congruent to angle H, and that's just easy to write. Here come the fun ones. Next, I'm going to go up the one congruency side and talk about angle K. But angle K is not over there by itself, so I have to be specific. So I'm going to say that angle JKG is congruent to angle HGK. And this tells me specifically which angle I'm looking at. And now, last but not least, I'm going to say that angle KGJ is congruent to angle, let's see, GKH. All right, and those are my 3 angles. Now I'm going to go over my sides. All right, I'm going to do the one congruency marking first, and just keep my sanity straight, I'm going to do triangle 1 on one side, triangle 2 on the other. And that's not a hard and fast rule, that's just a good way to stay organized. So angle J, or side JK is congruent to GH. And then I have JG is congruent to HK. Remember your congruency markings. Remember the notation. All right, so I have 2 sides. Triangles have 3 though. So you need to say that third side. And that third side is going to be GK is congruent to GK. And yes, you're saying that a side is congruent to itself. That is still important. You have to represent for the audience that the side is congruent to itself. And there you have it. There is the congruency statement and the 6 corresponding congruent pieces. You guys do number 11. The video is going to pause. When it plays again, you'll see the answer. And here's your answer. Now, if your name is different than mine, that's totally okay. I just went off of the congruency markings, so first, second, third, and the same on the other triangle. As long as the corresponding vertices are in the same order, totally fine. Okay, so as long as R is in the same position as J, as long as T is in the same position as K, L, and S, as long as they're in the same spot, then you're good. Now, small trick on the slide, and then we'll move on. An easy way to write out the congruency pieces is to go off of the name. And that's what I did. I didn't even look at the picture when I did the 6 congruent pieces. I just looked at my positions. R is congruent to J. T is congruent to K. S is congruent to L. And just kept going. I even did the sides that way. And so that's a really good way to make sure you get all 6 pieces if the pictures look a little weird. Write the name first and then list the pieces from the name, because you know the angles have to be in order for the name to be right. All right, let's keep going. Now, here's what I meant by sometimes pictures looking weird. Okay, they will not always be in the same orientation. However, there will always be enough information for you to figure out what the congruency pieces are. All right, what I want you to do on the slide, the video is going to pause. I want you to write out the congruency statement and list all the corresponding congruent pieces. The video is going to pause. When it plays again, you'll see the answer to number 1, and then pause again, and then you'll see the answer to number 2. Good luck. All right, and here are the answers to number 1. And in case you're curious, I just started at P because it had the first congruency marking, and then went to Q because that had the second congruency marking. If you did it a different way, that's fine. Just make sure you have the angles in order. Now, for polygons like this, you don't have a symbol up in front of the name. It's just the order of it's just the vertices listed. Okay, notice there are no commas. I just wrote them down. All right, number 2, go for it. And here's number 2. Now, if you are having difficulty with the congruent corresponding pieces, again, the best strategy I have, well, there's 2 strategies. Strategy number 1 is to read your name, okay? Put forth effort in getting your name correctly, the congruency statement, and then go off the congruency statement. So when I did this one, I went from L because it had 50, and then went around in ascending order of the angles. Why? Because I saw it first. And then when I went over to the other triangle, it did the exact same thing. Okay, once I did that, I didn't even look at the picture. I just went off of the congruency statement. Now, if you're having trouble reading the congruency statement, that's fine. Mark up your picture, okay? Do markings, do something. Okay, here's 40, it's congruent to 40 over here. 50 is congruent to 50 over here. 39, 39. And once you have those markings written down, then it becomes a lot easier to name the triangle. Okay, but have some sort of orientation to help you figure out, because the pictures will not always be in the nice, neat, simple, easy spots. All right, now that we've talked about what makes the triangle congruent, we're going to start drifting over into proofs. I know, I can hear your joy through the camera. Now, whenever you prove, whenever you show, and whenever you can demonstrate irrefutably that all 6 of those pieces of a triangle are congruent, then by definition, you have proven the triangle to be congruent. All right, but what if you want to go backwards? What if you want to say, hey, I have a congruent triangle, therefore, well, by definition, you know that the pieces of a congruent triangle are congruent. Now, to say this one in a proof, though, we use this really fun acronym called CPCPC. Or if you want, you can use the one underneath it, CPCTC. Okay, both of these mean very, very similar things. Let me explain this one first, because it's written out right there. CPCTC is corresponding parts of congruent triangles are congruent. Okay, so this is going backwards. The definition tells you that if the pieces are congruent, then the triangle is congruent. CPCTC tells you that if the triangle is congruent, then the pieces are congruent. It's just one way you go backwards. This is going to be really important in proofs when you're trying to prove information of congruent triangles are congruent. Now, the difference between the 2 names is not a very big one. I mean, it kind of is, but not really. T versus P. All right, they mean the exact same thing except for this one word. The P means polygon, okay? So this one says that corresponding pieces of congruent polygons are congruent. The bottom one says corresponding pieces of congruent triangles are congruent. You can pick either. Go for it. Use whichever one you want. I will say, though, that if you are talking about, if you're using this one, this name, CPCPC, works for all shapes, as long as it's a polygon. Okay, triangles, squares, rectangles, weird ones, as long as it's a polygon, it'll work. Now the other one, CPCTC, this one only works for triangles, okay, because it says in the name, corresponding parts of congruent triangles are congruent. Now we'll mostly be dealing with triangles, which is why I use this one, but if you want to use the other one, go for it. Just make sure that you only use the triangle one for triangles. That being said, let's solve some problems. Now, whenever you are solving problems, you need to be told that the 2 triangles are congruent. If you are not told the 2 triangles are congruent, you can't do anything. But if you do have that information, you know that corresponding pieces of congruent triangles are congruent. So you can use that information to solve for X and Y. So I'm going to do the first one with you, or number 2, and then you're going to do this other one off to the side by yourself. Here we go. Now we are told that RSV is congruent to TVS. What I'm going to do is I'm going to annotate this because I don't want to get things screwed up. So I know that RS is congruent to TV. Change colors. So RS is congruent to TV. And that means that angle V, no, what do I want? I want angle T. Angle T is easier to find. Angle T is congruent to angle R. So this angle is congruent to this angle. Always a good idea to annotate your picture first, that way you don't get things mixed up. Now I solve. So I know that 2y minus 1 is equal to 24, plus 1 to both sides. 2y is equal to 25, which means that y is equal to 25 over 2. Leave it as a fraction, guys. Or actually, fine, the picture gave you a decimal, so you are allowed to use decimals on this one. There, be happy. Now for the angle. I don't know what angle R is, but I can easily figure this out. This is a right triangle, and one of our corollaries we learned the other day was that in a right triangle, the two acute angles are complementary. So I know that R and V, or R and RVS, have to be complementary. So I'm going to do 90 minus 78, and that will give me 12. Ha ha ha. 12 is equal to R. That's R's measure, which means that X is equal to 12. And there you have it. All right, the video is going to pause. When it plays again, you'll see the answers for the bottom one. Good luck. So here are your answers. How'd you do? Did you get tripped up by the fact that the triangle is flipped? Hopefully not. Hopefully you looked at the name and you saw that A was congruent to E, and therefore that EF was congruent to AB. But if you didn't, keep in mind the name will always tell you which pieces are congruent, and a good strategy is to annotate the picture first. All right, now let's get on to everybody's favorite part, the proof. We're going to do a flow proof for this first one, and maybe for the next one. I've forgotten. We'll figure it out. All right, here we go. So we are given a lot of information as I look at this, which means that each of these givens is going to go in their own individual box. Now that's a lot to write, so I'm going to write it first, and then we'll process. All right, so I don't know about you, but part of the writing included the processing of the fact that there's not enough boxes for our given. Now normally I would just create another box, but I don't have any room on the slide, so, there it goes. All right, so now that we've written all this down, let's go ahead and process. So by process, I mean put it on the picture, see what we're missing, and then go from there. So I'm going to just go down the line. I know that WXZ is congruent to YXZ. I know that XZW is congruent to XZY. Then I know that WX is congruent to XY. And I know that WZ, forgot annotation, is congruent to ZY. All right, well, that's a lot of information. Now, as I look at what I'm trying to prove, I see that I have to prove the two triangles to be congruent, okay? Which means I need the other two pieces that I'm missing, because I only have two angles and I only have two sides. So somehow I need a third angle and a third side. So let's address the angle first. I know that two angles are congruent. Think back to what we did the last class. When I know that two angles of two triangles are congruent, I am allowed to say that the third angles of those triangles are congruent. And if you're thinking to yourself, third angle theorem, you are thinking correctly. The third angle theorem allows us to say that the third angle of a triangle, of two triangles, are congruent when the two other angles are also congruent to each other. So there we go. We got three angles. Now I need my third side. Well, as I'm looking, the one I'm missing is this one down the middle. Now, so that means that XZ is congruent to XZ. And why are these two things congruent to each other? Because of the same line. So this is going to be reflexive. Reflexive property. Now, reflexive property can come from the rest of the flow, or it can get its own thought train. That's a little crowded from my slide, so I just went with what we got, but it also works like this. Now I have shown that all 6 pieces are congruent, so I can finally say that triangle WXZ is congruent to triangle YXZ. And I know this to be true because of the definition of congruent triangles. Sorry if it's a little cramped, my video's a little off. All right, sign off and you're done. Here is our first proof. Remember, when you're trying to prove triangles are congruent, right now, the only way we know how to do that is by the definition. And the definition states that when all 6 pieces are congruent, then the triangles are congruent. So you have to prove all 6 pieces. Why don't you go ahead and try this one? Okay, don't get discouraged by the number of boxes. There's a lot of givens. Okay, try it on your own. When the video plays, you'll see it. And here's your answer. How'd you do? Couple of notes. This one is basically the exact same thing as the last one. The biggest difference is that the actual flow of the proof is just better than the last one. Each given gets its own box, and then we go from the information. So you can see my 2 side information pieces. Okay, from that I drew the other side. Now, yes, reflexive doesn't really need to come from anything, but it's side information. And when you're thinking of sides, you think of more sides. So that's why that came from that. And then down here, you definitely need that 2 angles are congruent in order to use the third angle theorem. And once we have proven that all 6 corresponding pieces are congruent, we get to use the definition of congruent triangles and say the 2 triangles are congruent. Now, the one thing we didn't use today was CPCTC, okay? Corresponding parts of congruent triangles are congruent. CPCTC. The reason why we didn't use this is because this one, by the definition, by the statement, says you have to have a congruent triangle first. All of these the 2 proofs we did, we were proving triangles to be congruent. Okay? Now, if you're told, hey, you have congruent triangles, then you can use this one. If you're not told, you've got to prove the triangle's congruent first. Okay? That's why we didn't use this one. All right, that's basically everything. Last thing we got to go over is a few sometimes, always, and never ones. Again, I can hear your joy through the screen. So, here we go. An acute triangle is never congruent to an obtuse triangle. In order for 2 triangles to be congruent, the angles have to match. The obtuse angle will never match with an acute angle. Right triangles are sometimes congruent to other right triangles. Okay? Just because it's a right triangle doesn't mean that the other 2 angles are going to match exactly. I could have a 45, 45, 90 triangle, okay, where these 2 angles are congruent, and then I could have what's called a 30, 60, 90 triangle. Oops. Okay, so that right off the bat, those are 2 right triangles, but the angle measures do not match. And so therefore these 2 triangles would not be congruent. So sometimes. All right, down here, if triangle ABC is congruent to triangle XYZ, triangle A, this one's a little bit tricky. Sometimes. Angle A is sometimes congruent to angle Y. The reasoning on this one is you could have an equilateral triangle. An equiangular triangle. Okay? Because if you have an equiangular triangle, then all the angles have to be congruent. Which means that even though A and Y are not in the corresponding positions, if it's an equiangular triangle, they're going to be congruent anyway because all the measures are the same. So that one is sometimes. Last but not least, same 2 triangles. AC is congruent to Z or XZ. This one's going to be always. Those are 2 corresponding sides, and therefore will always be congruent. All right, guys, that is the lesson. If you have any questions, please write them down and save them for next time, and I'll see you when I see you next.